Everyone, welcome to my YouTube channel Tech Talk with Rais. Today we are going to discuss a very important topic related to authentication. So without wasting much time, let us move on to today's topic, which is JWT Token, a way to stateless authentication. In this session we are going to discuss a complete login workflow. Let us move on to today's agenda. Here is today's agenda: authentication responsibilities, traditional stateful authentication, advantages and disadvantages of stateful authentication, foundational key concepts of stateless authentication, JWT token based authentication, token generation workflow, and token validation workflow. Let us move on to the next slide. In this slide, we are going to discuss authentication responsibilities. Let us assume that there are two parties, client party and server side party. Clients want to retrieve some data from the server, so this particular client must be authenticated at the server side. This complete authentication responsibilities I have categorized in two parts. The first part is credential validation, another part is something. So let's discuss the first part. When user supplies username and password from the client side, this username and password must be validated, and this responsibility comes under this part. Whether this user exists or not, if this user exists, then whether this particular password is correct or not. So these kind of things are validated in this section. The responsibility for this section is this: once this user is credential validated, then successive requests, for the successive request, it is bad idea that user gets authenticated again and again. This is a bad idea. Rather, once the user is validated, the user must be given a window and mark the user is logged in. That means for the successive request, the authentication credential validation will not happen. For that, the credential service or auth service should provide a mechanism or a way to make the user stay logged in or get a feeling of stay logged in. Stay logged in part comes under stateful authentication, where get a feeling of stay logged in comes under the stateless authentication. We'll discuss about all those steps in further slides. In this session, our focus will be this side only. We are not going to discuss the credential validation part, where basically username and password is validated. This part we are not covering much in this session. Rather, we are covering complete stay logged in and get a feeling of stay logged in part. That means stateful or stateless authentication part we are covering in this session. Let us move on to the next slide. In this slide, we are going to discuss about traditional stateful authentication. Like from the previous slide, I told get the user stay logged in. This part is covered in stateful authentication. So let us try to visualize how it all happens. There are two parties, client side party and server side party. Client has some user which sends the request to the server to retrieve some data. Let us assume that this particular user is already registered, and whatever credentials it is supplying, those credentials are valid. The first part, like credential validation part, we are assuming that credential validation part is completely successful, and that part is not shown in this picture. We are jumping into the second part, where we'll discuss about stay logged in part. So very first time when the user sends a request to the server, this request must be authenticated. For that purpose, the credential validations happen, which is not shown in the picture. Next, there is something called auth service or auth code, which basically does couple of things. This will save this session or some piece of information of this user into the DB and save it is a session which will have some session ID, something like that, and in return to response it will return the session ID in the form of cookie header, set cookie header back to the client. For the successive request, the client will set this session ID in the cookie header so that when it lands on the server, it will again check whether this particular session exists or not in the DB. If this session is present, that means the user is already logged in, and immediately whatever the request is for, the user will be served with this. Let's say in this particular case, user asked for the all the endpoints, then it is returned with the all the endpoints E1, E2, E3, something like this, and user is already logged in into the system. The traditional stateful authentication works in this way, where for every user authentication happens and the session is saved into the DB, and for the successive request lookup happens. Let us discuss about advantages and disadvantages of stateful authentication. In stateful authentication, it provides enhanced security because sessions are stored at the server side. It also provides great user experience because users are logged in into the system. It also provides flexibility for implementation in web, mobile and API based applications. In one side it is providing a lot of good advantages, but other side it is kind of provides a lot of disadvantages. Some of the disadvantages are listed here, like it increases server side load. In this model there is scalability issue, like if number of sessions are more or number of users are more, then we have to create more number of sessions, and these sessions needs to be maintained, and this is why there is a scalability issue. Because sessions are stored at the server side, so it is resource intensive, and also in this particular model it is very hard to implement complete logout process. Because there are a lot of significant disadvantages, it is preferred to use stateless authentication. These kind of disadvantages are mitigated in the stateless authentication. In further slides we'll discuss about stateless authentication. Before going to deep of the stateless authentication, let's discuss few foundational key concepts which will create a baseline for the stateless authentication. There are two such foundational key concepts. Number one is encoding and number two is cryptographic hashing. So encoding data is a process involving changing data into new format using a scheme. Encoding is reversible process. This is really important. Encoding is a reversible process and data can be encoded to new format and decoded to its original format. While encoding provides a security mechanism, encoding is not used to protect or secure data because it is easy to reverse. Example for encoding is like base 64 encoding, and practical usage is if you want to upload your educational degree to some web server, let's say, if you will upload just like that, your all private informations like mobile number, email ID, etc will become like public. If you want to hide that, you simply go ahead and upload this whole educational degree in base 64 encoded format, and whenever you want to retrieve it, simply download it and convert it or decode it using base 63 decoding algorithms, and you will get the original degree back. So this is kind of reversible process. Next foundational key concept is cryptographic hash functions, which basically maps arbitrary size of data to into a fixed length or fixed value size of the data. So hashing is a way of mapping data of arbitrary size to fixed size values using cryptographic algorithms called hash functions. The value returned by hash functions are called hash values, hash codes, digests, or simply hashes. There are some properties associated with hash functions. These hash functions are always one-way operations. They provide a fixed length output, and the good hash functions provide a collision free outputs. These two concepts are the key foundational key concept which provides baseline for the stateless authentication. Let us move on to the next slide. In this slide we'll discuss about stateless authentication using JWT token. So basically we are going to discuss a token based authentication in this particular slide. Like from the previous slides, let's assume that there are two parties, client side party and server side party. Client is requesting or kind of asking server to for some particular data and want to retrieve some particular data, and for that he is supplying username, password and some kind of metadata. Let's assume from the previous slides we have already seen, let's assume that the user already exists and whatever password it is supplying that are valid. So that here my point is basically we are trying to avoid credential validation part. When how it works, basically a server has a particular service called auth service which is responsible for token generation and token validation. This model how it works basically is client requests a token from the server and gets a token back. This token is provided by this auth service. How this token generation happens or how this token validation happens, we'll see all those steps in the further slides. But at a very high level, let's understand this, that this auth service will provide this client a token, and this particular token this client will save in the local site, local DB or local file system or local site. It will save this token. In the successive requests, client will simply use this token in the headers, and once the client request for some particular resource and it is using that token, then at the server side auth service will validate whether this particular token is valid or not. If this token is valid and exactly kind of it is same what it has provided it to it, so that means token is valid and it will immediately serve the client with the requests. So this is how this JWT token based stateless authentication works, where JWT token stands for JSON Web Token. Why it is called JSON Web Token? Because this token generation takes input data in the form of JSON. All those steps we'll discuss in the next slide. Before going to the next slide, one important thing here to note is basically server is providing a token. Client can use that token to retrieve data. But what if this token is saved here at the client for forever? That means that is a security threat or risk, and this is why this auth service should provide a TTL or expiry time for these tokens, otherwise they might create a big security threat. So this thing we have to keep in mind. Let us move on to the next slide. In this slide we'll discuss about how JWT token generation workflow looks like. We will see complete workflow for the token generation. From the previous slide we have seen that client requests a token from the server side. At the server side there is a service called auth service which is basically responsible for token generation and token validation. This service only basically calculates a token and returns the token to the client. How this token generation happens? The client sends a request in the form of get token and it passes credentials. At the very first stage the credential validation happens, like in the previous slides I have shown you, like username and password will be validated whether this user exists or not. If user exists, then whether password is correct or not. This kind of things happens here. Once credential validation is successful, token generation is taken care by the a component called token generator or something like that. What it does, it basically constructs three parts. Part 1, that is called header, part 2 that is called payload, and part 3 something called signature. Before we go to individual parts, let's understand one more thing. At this server side there is a fixed secret key. This fixed secret key is available only at the server, and this is completely fixed. It can be a private key or public key, whatever, but it is fixed and only available at server. It will not be shared with anyone. Next, let us understand these three parts. This token generation, this token generator, what will it will do? It will create three subparts: one part, second part, and third part. The first part is called header. In the header, it creates a JSON format data. In the payload also it creates a JSON format data. In header, what items it has? It had basically algorithm and type. Like type is basically JWT token type. Algorithm is like which hashing algorithm we are going to use to generate signature. Which hashing algorithm we are going to use generate the signature. We'll come to that. So it constructed the header. Next, whatever the input data we had supplied, like username, password, and whatever the role of this particular user, let's say admin, auditor, and something like that, and some other metadata we had supplied. So based on the user provided information like metadata information and user information, based on those information it constructs a payload like username, role, logged in as, ID, something like that. This kind of data it creates in the format of JSON. Remember here, so one thing to remember is like it does not put anything sensitive in these blocks, because these blocks are going to be encoded, and from the previous slides I have already explained that encoded data can be reversed back to get the original data. So this is why we don't have to put any sensitive data here. Any token generation service should not put any sensitive data here. So in the payload it basically constructs some kind of metadata information payload. In the header it basically constructs algorithms, types, and some other things like key, etc., which is not shown, to generate a signature. Like to generate something called signature, whatever inputs should be there, it can come from the header part. Next, this header is base64 URL encoded. So it returns something like this. If we encode this header in base64 URL encoding, then we get something like this, and the same thing we supplied it to the signature. Similarly, this payload is also base64 URL encoded, and we get something like this, and the same thing again is fed to the signature part. Now we have constructed two parts, like this part and this part, like base64 encoding of the header, base64 URL encoding of the payload. Two things we have constructed. Now third part is like signature. How we will construct signature? We have fixed secret key which is only available at the server side. We take that like key, and we are taking base64 URL encoding of the header and base64 URL encoding of the payload as inputs, and what we are doing, we are creating a hash out of that. And what algorithms we are going to use? We are going to use SHA-256, which is hashing 256. So this is algorithm what we are going to use to perform a hashing operation on these inputs like secret, base64 URL encoding of header, base64 URL encoding of the payload, and we'll put a dot between them. So like this whole thing, like base64 URL encoding of the header plus dot plus this, like this whole part, if you understand this whole part will be supplied here, and this will be signed off kind of with this secret key, and the hash will be generated. Whatever hash is generated, that will be again passed to a base 64 URL encoding function, and whatever random number or random text we achieve, this is our base 64 URL encoding of the signature. So essentially we have got three parts: header part, payload part, and signature part. All of them are base 64 URL encoded, and we will join them using dots. This whole three parts joined with dots is called JWT token. This whole JWT token which is generated, we will return back to the user. User will save it to the local machine, and for the successive calls they will use this token for the successive user requests or client side requests. And in one more thing, in the payload we can also have, we can set basically a TTL or expiry time for this particular token. This way, this is the complete JWT token generation workflow which is written to the user, and user uses this for the successive calls. Let us move on to the next slide and discuss how validation workflow works. In this slide, we are going to discuss how token validation workflow works. From the previous slide, we have seen that the token is generated, and now user is requesting for some particular resource, and in his request header he is passing this token. Let us see how the validation works. The request again lands on the auth service which is responsible for the token generation and validation. In this particular case, it will be responsible for the token validation. What it does, it splits this whole token from the dot point, the connector part, like this connector dot was connector. So from the connector it will break this whole token, like we'll get three parts. The first part is called header, second part is called payload, third part is called signature. Now what we will do, we will decode it. This header part we will decode. After decoding, what we'll get, we'll get the algorithm, hashing algorithm to generate this basically signature and what type of the token we are going to generate. This part will get. Again, we already know that this fixed secret key is already available on the server, and which is fixed at the server and it is not shared with anyone, right? So if we get this part and we get this part, how we are generating our signature from the previous slide, we are kind of making getting a hash out of base 64 URL encoding of the header plus dot plus base 64 URL encoding of the payload. That means if we get these two parts joined with the dots, we have taken it directly. We are using this secret, and we are using this algorithm to create a hash function, and we will pass to this hash function and we'll get something called a signature, and this signature will again pass to base 64 URL encoding, and finally we will get this base 64 URL encoding of the generated signature. This will be generated signature which will be generated from the payload and header, and then we'll match this generated signature with the actual signature of the token. If they match, that means login is successful, or basically user is authenticated. If doesn't match, that means user is not authenticated or it's not successful. This is how the validation works. Let's assume that someone changed something. I mean, while passing the kind of request, someone changed the, let's say, payload section, because it can be easily decodable. So someone decoded it, and after decoding it he passed like let's say some admin role which was earlier auditor role only. So what will happen, this whole function, this whole generated hash will get different. We will get a different complete hash out of that, because anything supplied to a hash function, any different input supplied to the hash function will create a different output. So this again, this whole signature will again not match, and this login will not be successful, the credentials will not be valid kind of. So this is whole token validation workflow is. This is a great way of handling scalable system, and whatever there were disadvantages of stateful authentication, all of them were mitigated here. Let us talk about advantages and disadvantages of a stateless authentication using JWT token authentication. So in this slide we'll discuss about advantages and disadvantages of stateless authentication. Here are advantages like scalability. It works great with horizontal scaling. The server side load is also reduced. It is very fast and performance optimized way of authentication. There are some disadvantages like security risk, because we are storing token at the client side rather at the server side, and it can be hacked from the client side. So we have to kind of set up a TTL, and basically in this model there is no way to terminate session or something like that. This is why a complete token management is required. Also in this model there's a lack of session management, so like logout from all devices kind of things are not there in this kind of model. Hope this video is helpful for everyone. If it is helpful for everyone or helpful for you, kindly like this video and subscribe my channel. Thanks a lot.